this lecture we study the transistor is an amplifier and also H parameter models. How to draw the H parameter model for all three CB, CE, CC configurations. Now here this is the common base configuration. If I change a small voltage at the input, then here if I change a small input voltage, with that there is a change in the input current, because this is a PN junction and we are applying the forward bias. A small change at the input, it will lead to the change in the IE current. So if IE current is changing, then IC current is also changes. Why? Because in a common base we have studied that current gain alpha is equal to delta IC divided by delta IE, or now here DC amplification factorial, right? So alpha is equal to IC divided by IE. So if there is a change in the input, then there is a change in the output. How many times? It's IE is equal to, what can be right? IE is equal to alpha times IC. So now here if I change the small voltage, thereby the input current changes. So there is a change in the output current, that I am writing it as a change in input output current to the change in input current. I am writing it here, I am taking it as a alpha dash, that is equal to IC divided delta IC divided by delta IE. Delta IC divided by delta IE. This change in current, if it is passing through this resistor, RC resistor, then there is a voltage drop. That voltage is called as the output voltage V0. We can write it as V0 is equal to alpha dash RC into IE. This is the expression. Now this voltage is greater than the input voltage. With this, now if you take the gain, voltage gain, AV is equal to output voltage divided by input voltage. Now this gain is greater than 1. So with this we can say that, so the circuit will amplify the signal. So this is the working of the transistor as an amplifier. Now we see how to draw the H parameter model for the transistor. Now why the name H parameter model means, now here we are going to calculate 4 parameters, and all those 4 parameters are not having the same dimensions. That's why the name is H parameter model. Now if I take a 2-port network, now here this is a 2-port network, and input is a V1 and input current is a I1, output current is I2 and output voltage is V2. Now for this, now here in this V1 and I2 both are the dependent variables. Similarly, V2 and I1 and V2 both are the independent variables. So independent variables. Now if I write the expression, these dependent variables in terms of independent variables, then V1 is a function of 2 variables I1 and V2. Similarly similarly I2 also I can write it as a function of I1 and V2. So if I write the, now if any changes in the inputs, then we can write the total differential equation. So here delta dou V1 is equal to dou V1 by dou I1 and dou I1 plus dou V1 by dou V2 into dou V2. This is expression 1. And similarly for second expression, if I take dou I2 is equal to dou I2 by dou I1. So this expression I am writing in terms of V1 and V2. So dou I1 plus dou I2 divided by dou V2 into dou V2. Now this is the expression number 2. Now if you see here it is a difference ratio of change in input voltage to the change in input current is we can take it as, this is nothing but here I am writing it as a H11. So why I have to represent the H parameter? H already I said that because of the different dimensions we are representing this as a H. We are denoting with a H. And H we call it as a hybrid, because mixed parameters are there, we are calling it as a hybrid. So here this I am writing it as a H11. Why 11? H indicates what? Hybrid. 11 indicates what? This is the input voltage, this is the input current, that's why H11. Similarly this I am representing it as a H12, input voltage, output voltage. So here this we can represent it as a H21, output current, input current. And this we can represent it as a H22. So now here if I write a H11 is equal to what? H11 is equal to V1 divided by I1. Nothing but what? Impedance. This is the input impedance, both input voltage, input current. That's why it is an input impedance. So this I can write it as a HI. Here the second suffix I am taking. So this is a HI. Now second one is what? H12. H12 is nothing but what? V1 divided by V2. So V1 divided by V2. Generally gain is equal to what? Output divided by input. But here if you see, this is the input voltage divided by output voltage. Here we are taking it as a reverse voltage gain represented by HR. Similarly, now if you take H21 is nothing but I2 divided by I1 is nothing but output current divided by the input current. So this is nothing but a gain. So we are representing it as a forward gain. So we are representing it as a forward gain HF. Similarly, one more term H22 is equal to I2 divided by V2. Output voltage, ratio of output voltage to the output current to the output voltage. So ratio of current to the voltage is called admittance, and both the parameters are output side. So this we are representing it as a HO. So these are the four parameters we need to derive from this. These are the four parameters. By using this, we need to construct the H parameter model for the transistor. So now here, if I draw the diagram for this. Now, if I write the same expression, V1 is equal to HI and input current I1, the same expression I am writing. V1 is equal to HI input current and HR output voltage, HR into output voltage. Similarly, I2 is equal to HF input current and H0 output voltage. Now these are the two expressions for the transistor, two port network. So now if I try to draw the diagram for this one, now input is what? Voltage is equal to, this is one voltage drop, this is the second voltage drop. So for that, what we have to use? We have to take the loop. For the input side, we have to draw the loop. Now here I am taking, this is a V1 voltage we are applying. Now this is a drop, nothing but what? Current into resistor. So impedance, current into impedance. This is the impedance and this is the impedance HI, and this is the current I1. And the second one is a dependent voltage source. So this is a voltage source, dependent voltage source, and representing as a HR V2. V2 is the output voltage. So this is the diagram for the expression 1. Similarly, we need to draw the diagram for the expression 2. For that what? Now this is I2. So total current is equal to what? Now entering current is equal to leaving currents, or algebraic sum of all currents is equal to 0. So there we need to apply the node. So here output side, if I am taking the node. So this is the dependent voltage source. Now this is the I2 current. I2 current is equal to what? Now this is the dependent voltage source HF, and it is depending on the input current I1. And if you see here, HO is nothing but admittance. This is admittance, and the voltage drop across this is V2, or output voltage is V2. Now this is the diagram for the transistor. This is the diagram for the common transistor, two-port network. So if we wanted to draw the diagram for the common base and the common emitter, the same diagram we have to draw, but only thing is, what is the input current, input voltage drop, output current, output voltage drop, that we have to consider. Instead of writing the generalized expression HI, I1, I2, HF, HR, H0, we have to take the, for common base means what? Second suffix we need to use the B. Common emitter means second suffix we have to use the E. Now here, common base means what? We have to put B. Common emitter, we have to put E. Common collector, next second suffix we have to take it as a C. That's all. to represent H parameters like that. And also input current, input voltage, output current, output voltage. What are the parameters in the common base, common emitter, common collector? Accordingly we have to take. Okay. Now here I will show you how to draw the H parameter model for the common base and common emitter. So now if it is a common base, now if I am taking the common base, so this is the common base. Input is emitter, output is collector, and the common terminal is base. Input current is IE current and output current is IC current, and input voltage drop. Now if you see the junction, this is a E and B, so VEB. And what is the output voltage? Now this is the collector and this is a base, so VCB. So this is the common base diagram. So now for this, if how to draw the H parameter model, we have seen that input side we have to use the loop, output side we have to take the node. Input loop I am using, so one input impedance and voltage source. And what is the input voltage? VEB we have to take. And what is the this input impedance? HIB. Because this is a common base configuration, we have to show it as a second suffix is a B. And what is the current in the input? It is a IE. And what is the dependent voltage source? HRB. And output voltage we have to take VCB. Similarly, output side we have to put node. So node, one dependent current source in parallel with the admittance. Now this is a HO. And what is the output voltage? VCB. And what is the current? IC. And what is this dependent voltage current source name? HRB. HR is nothing but a current source or current source. Now it is depending on the input current IE. Now this is the H parameter model for the common base. Similarly, if we try to draw the H parameter model for the common emitter, then how to draw the common emitter? So this is the common emitter diagram. In this, emitter is a common terminal and base is the input terminal, collector is the output terminal. Input current is what? IB, and output current is IC. Input, what is the voltage here? VBE. And what is the voltage? VCE. Same diagram, just we have to represent the common emitter parameters, current and voltage parameters. Now this is the diagram. Now input voltage is VBE. Now here this is a HIE. Now because this is a common emitter, second suffix we have to denote it I. And what is the input current here? IB is the input current. And this is a dependent voltage source, HRE. What is the output voltage? VCE. Now similarly at the output node we have to take and draw the admittance. And what is the output voltage? Output voltage is VCE. And what is the output current? IC. Now this is the IC. Now here we should not represent. Here IC. This is IC and this is a HOE and this is a HFE, and depending on input current IB. That's all. This is the H parameter model for the common emitter configuration. Similarly for collector also, common collector also you have to draw. Now here I will show all the diagrams, all three diagrams at a time. So this is the hybrid model for the all common base, common emitter, common collector. Diagrams look like same, only the difference is you have to see that what are the input current, what is output current, input voltage, output voltage, accordingly you have to put the values. So this is about the hybrid parameter model. And the next one is comparison table. So this is the CBCE-CC. So just now we discussed the configurations. So now here we will see the comparison. So voltage gain is output divided by the input. Now in the common base it is moderate. In a common emitter it is high, around 500. Common collector it is less than 1 value. Now similarly current gain, here it is alpha, beta, gamma. Alpha is less than 1, beta is around 100, or you can say it as a 50 to 500, and gamma is almost is equal to beta. And here phase difference, when we apply the signal at the input, output we don't get any phase difference in the common base and we don't get any phase difference in the common collector, but in a common emitter we get 180 degrees phase shift. Similarly, input impedance, it is low in the case of common base. Why? Because input we are applying forward bias, that's why input impedance is low. Output we have applied the reverse bias, that's why here it is high. In the case of common emitter, though we have applied the forward and reverse, but here what happens, input current is in the common emitter configuration, input current is low, that's why we are getting medium more than common base. In the common base, input current is IE. IE is in the order of milliamp. That's why here we are getting the low. So IE is in the order of milliamp. Here IB is in the order of micro. That's why here we get the low resistance. Here we get the medium. And in the case of common collector, if you see the common collector configuration, we are applying the reverse because base emitter, base collector both are input side. We applied the reverse. That's why high current, high resistance. So output also, now we already have explained this, we have applied the reverse. IC is in the order of milli, that's why we are getting high. Here it is medium, and here we applied the emitter is output terminal, is a forward we applied, that's why it is low. And coming to the common base, we use this for the high frequency amplification, and the common emitter we use for the audio frequency amplification, and the common collector we use for the impedance matching. So this is about the comparison of 3 configurations. Thank you.